question is from GATE 2017, Mechanical Engineering Paper Set 1, question number 23. In an arc welding process, welding speed is doubled. Assuming all process parameters to be constant, the cross-sectional area of the weld bead will option A increase by 25%, option B increase by 50%, option C reduce by 25%, option D reduce by 50%. Let's look at the given information. So we are being given that the weld speed is being doubled. We can write second weld speed, that is V2, is equal to 2 times the first initial weld speed, that is V1. And we have to find the relation between A1 and A2. Now, starting with the concept of deposit rate, we have rate of depositing the weld metal is equal to area of weld into the welding speed. Now, as it is given that all other process parameters are remaining constant, we can say that deposit rate remains constant. When the welding speed changes, area of weld is going to change, keeping the depositing rate constant. Hence, we can write A1 V1, that is initial area and initial velocity of weld, is equal to A2 V2. Now, we have the relation between V2 and V1. So, let's just put V1 in place of V2. We have A1 V1 is equal to A2 into 2 times V1. This gives us A1 by A2 is equal to, hence final area A2 becomes half of the initial area A1. So if weld speed is being doubled, area is halved. And when it is halved, that is, it is decreased by 50%. Hence we can say area is decreased by 50%. Option here which is correct is reduced by 50%, option D. To learn more about the welding processes, you can refer to the NPTEL video Physics of Welding Arc Part 4 by Professor Murugaiah Amirthalingam from Joining and Manufacturing Laboratory. He is from Department of Metallurgical and Materials Engineering, IIT Madras. I hope this explanation will help you clear your doubt. Thank you.